Hello everyone, this is part 2 of solving Einstein's Riddle problem using integer programming. So in the first part of this video I talked about how we can set up the variables, and I showed you how we can write the constraints, the equality constraints, the inequality constraints, and in this part, which is part 2, I'm going to show you how we can program it in MATLAB or basically any other programming language. So just quick recap, we had 125 variables, 5 variables for every type of color, nationality, cigarette, pet, and drink. Okay, so I have a column here that indicates the variable number. Like for blue, I have variable 1 to 5. For green, I have variable 6 to 10 all the way to 125. Okay, so we can put all of them into a vector. So if you go down, I have a vector, let's say x. In this x vector, I have 125 columns. Okay, so basically this is like a row vector. If you think about x transpose, so x is going to be column vector, then x transpose is going to be row vector. So the first 5, I call it our blue identifier. The second 5 variables are green identifier, and then the last 5 will be, let's say, the fish identifier. So the overall is going to be 25 of these groups, which add up to 125 columns. Okay, so with that, we can go ahead and program this in, let's say, MATLAB. So here I have coded in MATLAB already. So we have 125 variables. I have 2 sets of matrices, one for equality constraint. So this is the equality constraint, and this is the right-hand side of the constraint. And I have inequality constraint matrix and their right-hand sides. Okay. So first we set up the equality constraint. Remember, one part of the equality constraints where we had a sum of rows and columns to be 1. So in this section, I'm setting basically 50 constraints, right? 10 constraints for every block, and what I mean by block is the color, nationality, cigarette, pet, and drink. So we have 10 equations or 10 equality constraints for every type. Okay. I just go over one of them. Like if you want to set the sum of rows for column to be 1, then this is what it is. Okay, so we have 5 rows, 1 row for blue, 1 row for green, 1 row for white, yellow, and so forth. And so for every row we get 5, 1 in that row, and all other entries in that row is going to be 0. Okay, so we have basically, there's a loop here that goes over 5 blocks, and in every block we generate 10 constraints, so that's why we have 10 constraints here. Okay, again, this is the sum of rows. The first block is the sum of rows equals 0, and then the second block is the sum of the columns. The next part is setting the constraint for something like British lives in the Red House, or Swedish keeps dogs, things like that. Again, we convert these into rows of that equality matrix. Okay, like in this case, we want to multiply. This is basically j times. If you go back to the notes that I had here, so let's look at that constraint as an example. So if I want to convert this into a row in that matrix, then the x's are the variables, so I have to just put the j's, in the matrix. So that's why I only have j's as the coefficient. So this is the j for the first term, this is the j for the second term, that's why it's negative. And they go to the corresponding column, like British occupies a row, column 26 to column 30 in that matrix, according to the notes here. British takes variable 26 to 30, so these columns should be 1 to 5. And similarly for Red House, so go back here, the Red House takes variable 11 to 15. So then 1 to 5 should be in column 11 to 15 with a negative sign, because the arithmetic sum is going to be 0. Okay? So the right-hand side for these constraints are 0, but the right-hand side for the sum of rows or columns, so in this case the right-hand side, are 1. Okay? Okay, so after the equality, then we go to inequality constraints. We have 4 inequality constraints to be less than 2 and greater than -2, or less than or equal to 1 and bigger than or equal to -1. So it's the same thing. I just create a different matrix here, A inequality. These are the coefficient for inequality constraints. And then the right-hand side, I just set to 1 and -1. So the first one is 1. The second one is -1, but if you multiply the whole inequality by -1, the right-hand side still is going to be 1. And the thing is, in MATLAB, when you use integer programming, you have to convert all the constraints to be something less than. Okay, you cannot have a greater than constraint. So that's why both sides of my inequalities are 1. However, I flip the negative sign. Let's just move it from the second term to the first term for the second constraint. Okay, but this is the same inequality. There's no difference. Again, the issue is in MATLAB, the inequality constraint should be always less than or equal to. You cannot have a bigger than or equal to constraint. So by just multiplying through any bigger than or equal to constraint, you're going to convert that into less than or equal to constraint. Okay, so that's it. Basically, the last part is to write the objective function. So I consider 16 cases, and depending on which case we're going to look at, we have the +1 or -1 prefactor for every term in the objective function. So going back to the objective function one more time. So this was the objective function. So either this is positive, or this is positive, or this is positive, or the last one positive. We're going to have +1, +1, +1, +1. So if, let's say, this is negative and the other ones are positives, then we get -1, +1, +1, +1. And I have all those 16 cases in here. So we're going to look through this, and every time we're going to look at one case, and then write the objective function depending on this is positive or negative. I think it's very straightforward. Again, the coefficients are just 1 to 5, nothing else, because those are the house number, right? And we want to maximize this. So the lower bound, upper bound for the variables, since these are integer, the lower bound is 0 and the upper bound is 1. Okay. Overall, we're going to have 125 integer variables. So I'm saying here that all the variables are integer. I'm using the integer linear programming in MATLAB, and the maximum number of iterations is 10 to the 6, but you never reach to this. Actually, the problem can be solved really quickly because all of the constraints and objective function, all of them are linear. So this is really quick, so that should not be any concern here. And this is the line I wrote for the linear programming part. So this is the x, this is the final objective function. This is the exit flag, whether this is converged or not, and some other outputs. The objective function, the coefficients for the variable in the objective function, again, this is 125 by 1. Or if you think about the transpose of it, it's going to be 1 to 125 columns. The number of integers, we have 125. Then inequality constraint, the right-hand side of the inequality constraint. Then equality constraint in the right-hand side. Lower bound, upper bound, and what algorithm we'll be using, which actually is driven through this line where I set the options. So we're going to only pick if we converge, so if the exit flag is 1, and if the maximum objective function is 4, or because, again, in MATLAB, the optimization is through minimization, so MATLAB doesn't have maximization. If you have any maximization problem, you have to convert it to minimization, and that's very straightforward. You just multiply the objective function by -1. So any maximization will turn out to be a minimization. So if you want to maximize to be 4, because we had 4 constrained to be 1, right? By multiplying through, we get minimization, and the minimum value should be -4. So we're going to minimize it such that, the least value we get is -4, because all of the constraints should be 1. Well, because we multiply by -1 to convert maximization to minimization, overall minimum value is going to be -4. So we're going to exit when the minimum is -4, and then the rest is just the printing, right? So converting the variable 1 to 5 is going to be color, so just convert to 5 by 5 matrix. Again, row 26 to 50, which is for nationality, just convert to 5 by 5 and just print the matrices. So I'm going to run this, and what you see here is it's going to run through 16 cases, but it's going to stop at case 7, where the minimum -4 occurs, and then it's going to print out the matrices. So here we go. These are the solutions, and what we see is the color. Again, all variables are 0 or 1. They have to sum to, every row has to sum to 1, and every column has to sum to 1 as well. Okay, and you can also go and check other constraints. But this is a quick check to make sure that at least we satisfy the integer programming part of it. Okay, so I hope that is useful. Let me know if you have any question by posting a comment on YouTube. Thank you so much.